So today is the 7th, and today we're going to talk about dilations. And we're also going to talk about this thing called a zoom factor. Zoomy? There's no E in zoom. I don't know. I'm spelling it the British way. That's not actually British. This is often called the scale factor in other books. For some reason, ours calls it the zoom factor. Do you guys know what dilations do? They can shrink things or make them bigger. They can shrink things or they can make them bigger. They can also kind of move things around because we dilate about a point. So remember with our other transformations, when we're reflecting, we have to say what line we're reflecting over. When we're doing a rotation, we have to say what point are we spinning it around. With a dilation, we do have to dilate it about a point. So the figure has to both be the same size or the correct size at the end, and it needs to be in the correct location. And I'll help you with this. It's not terribly difficult. Let's go ahead and look at our first example. So I'm going to modify our instructions on this a little bit. So we're going to take this figure and we're going to dilate it a few times. Let's start by dilating about the origin. You guys know the coordinates of the origin? 0, 0. By a factor of, let's go 2. So we're going to dilate it about the origin by a factor of 2. So that fact that we're doing it about the origin is important, and you'll see why in a moment when we dilate it about a different point. All right. So currently A is at the coordinates 3, 2. Does anybody know where A prime is going to end up? It's going to end up being 6, 4. Yeah, 6, 4. So here's how I think about it. If you think about the center of dilation, the origin here, to get to A, I would need to count up 2 and over 3. We just need to double those things and count in the same directions. So instead of up 2 and over 3, I'm going to go up 4 and over 6. So go ahead and from the origin, count up 4 and over 6. Oops. Didn't count very well there. And you can go ahead and label that A prime. Let's go ahead and do the same thing for B, C, and D. So looking at B, it looks like to get from the origin to B, I'd go up 2 and into the left by 1. So double both of those. Up 2 over 1 becomes up 4 over 2. And that would be B prime. I'll leave C prime and D prime up to you. All right. There's a couple quick things we can do to check and make sure we did everything correctly. What was the original length of side CD? How far was it from C to D originally? It was 3 originally. I'm counting 3 spaces also. Count the length from C prime to D prime. If we did things correctly, since it's a factor of 2, it should be twice as long. So originally it was 3. Is this 6? Does that work for, it would be easy to do the distance from B to A. Count from B to A, that's 4. And then do B prime to A prime. Is that twice as big? It is twice as big? Okay. There's another quick way we can check. What do you notice about, let's focus on BA and BA. Again, what do you notice about those 2 line segments, those 2 sides? They are parallel to each other. And if you look at BC and B prime, C prime, see how those are parallel also? So those 2 things should hold when you do a dilation. You should end up with things that are parallel, and the lengths should be the scale factor away. So we're going to do one more dilation with a factor of 2. I'm going to do this in a different color, but you could do yours with like dashed lines or something. Let's do about the point 5, 5 by a factor of 2. So this time we're using, and we're doing our original. We're going back to the original again. We're using a different center for our center of dilation. We're not using the origin anymore. All right, good question. So I like when we do these, I like to start with the points that are furthest away because those are the hardest. So which point's furthest away from our center? Let's start with C. So give me instructions to get from our center to C. I would need to go down how far and to the right how far?
Down 7 and to the left.
Thank you for that correction. Down 7 and to the left by 7, correct? So we just need to double those directions. So start back at your center of dilation. Instead of going down 7 over 7, go down 14 over 14. I know this is the hard one. We chose the hard one to do first. It gets easier from here. So we're just doubling our direction. So before we went down 7 over 7, now we're going to go down 14 and over 14. So 5, 10, 14. And that's going to get us to C prime. I don't think I did that right. What did I screw up? That was not right at all. Where is it? It is right? Yeah. Okay. So something we can do to check here. So we were talking about C. So if I line up a ruler, my center in point C and point C prime should be all in a line. It was 14, 14. Yep. From here though. From here. Make sure you're going from here. So we're not going from the origin anymore. This is what gets tricky. So this is our new point. We're always counting from here now. Are we good on that? Yes. Where did the 7 come from? So I was looking at C originally, and I was comparing it to my new center of dilation. My first question was, give me instructions for how to get from my center to C. And the 7 came from the fact that we had to go from here to get to C. I had to count down 7 and then over 7. So we have to figure out, how do I get from here to this one? So I counted down 7 and over 7. Go ahead and sketch those arrows on there if you think that might be helpful to you. And then we doubled that. So we counted down 14 and over 14. I went a little too far there. Does that help a little bit? Thank you for that clarifying question. I appreciate that. So let's do the same thing for B now. Okay? So start at your center of dilation and give me directions from the center of dilation to B. How far down and how far over do we need to go from the center to B? Looks like down 1, 2, 3, and over 1, 2, 3, 4, 5, 6. You guys seeing down 3 and over 6? So what are we going to get if we double down 3 and over 6? Down 6 and over 12. Okay, so let's do it. So let's count down 6 and over 12. This is going to start getting a little messy, and then we're going to move over to the next page. That was too far. Hang on. All right, sorry. Counting down 6 gets me to here and over 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 should be there. My bad. All right, let's go ahead and do D. We'll save A for last because it'll be the easiest because it's closest. What are my directions from the center to D? Down 7 over 4. So now we need to count double that. So down 14 and over 8. So we've already counted down 14 and then over 8. 1, 2, 3, 4, 5, 6, 7, 8. Here's D prime. Does somebody need to get their phone silenced? Yes, please. Thank you. All right, and finally A. Give me directions from the center down to A. Looks like down 3 over 2. So we're going to double that and go down 6 over 4. So down 1, 2, 3, 4, 5, 6 over 4. 4. It's actually going to do a little bit of overlapping here. That's okay. And then we will draw our new shape. All right. That got a little messy, didn't it? If you had to choose which point to dilate about, which point would you choose? Would you have chosen the origin, or would you have chosen some other point? I think the origin's usually easier. The origin's usually easier. It turns out, this is getting a little advanced, but for those of you who do CAD stuff, this may become pertinent to you at some point. It turns out that you can always dilate about the origin and then just do one more transformation afterwards. So if I wanted to do this about this point, I could have first dilated about the origin, and then what would I do to turn this blue quadrilateral into this red one? Just translate it. And how far would I have translated it? Down 5 and over 5. Basically the opposite of where our center was. Our center was up 5 and over 5. We would have just translated in the opposite direction. But it's really just a matter of counting. So let's practice one more at the origin. Actually, we'll do two more at the origin. Keep it simple. So for this one, could you dilate it by a scale factor of 4, centered at the origin? So our center is at the origin right now. So I'm going to do R first. From the origin to R is up 1 over 1. We need to dilate by a factor of 4, so multiply that by 4. Up 1 over 1 becomes up 4 over 4. There is actually a shortcut to this if you are dilating about the origin. You can just find your coordinates. R was at 1, 1. You can multiply it times those coordinates both times 4, and you'll get R prime. It would be at 4, 4. So when I'm dilating about the origin, rather than count, I'll actually write down the coordinates and do it this way. S was at 0, 1. So S prime should just multiply both of those times 4. 0 times 4 is 0. 1 times 4 is 4. E was at, bless you, negative 2, negative 2. Multiply times 4. And Q is at negative 1, negative 2. Times 4 gets us negative 4, negative 8. Something's wrong here. I didn't count right. All right. Well, at least I'm in good company. This was what did I say? That was P prime negative 8, negative 8. I did negative 8, negative 7, negative 8. I think we're good now. Yes. I drew that line and I didn't see something that was parallel. That's what made me second guess. My counting was indeed off. All right, your final shape should have sides that are 4 times as big as your original. And all those sides should be parallel to the original sides. Yes? Man, did I count that wrong too? Oh, negative 10 is, that's misleading. Negative 10 is down here. You're right, it is. All right, grumble, grumble, grumble. All right, we'll fix this one more time. I was going based off of the labeling, but the labeling is kind of off-centered. It's a little confusing. Whew. It's a good thing they make whiteout tape. Is that looking better? So this is tricky because negative 10 is right here. So negative 8 would have been right here. Same thing here is negative 8. We'll be very careful with our coordinates on the next one.
That isn't even right. Q is negative 4, comma 8.
Negative 4 comma negative 8.
Yeah. So why would you?
Because here's negative 5, negative 6, negative 7, negative. So the you know what's throwing us off?
I read it the wrong.
No, guys, I think what's throwing us off is that this negative 10 makes it. We're going to run into this problem down here too. This negative 10 makes it looks like here is negative 10, but it's actually right here is negative 10. That's what was throwing us off. And same thing up here. This is negative 10 right here. 9, 8, 7, 6, 5. Yeah. So the way that the axes are labeled is a little bit confusing here. Negative or positive 10 should be here. It would just be 10. You're right. Positive 10. Thank you. All right. So I will make sure that when we have our next test that the axes will be clearly labeled, so we won't run into this issue. Okay. So knowing that it's easy to make mistakes, we'll be super careful with this. I think that this one would probably be easier for us to do by finding the coordinates of each of these points first. And since we are going about the origin, we can use our shortcut where we just multiply those coordinates times the factor of 1/4. Excuse me. Multiplying by 1/4 is the same as dividing by what? It's the same as dividing by 4. So hopefully all these coordinates will be easily divisible by 4. I don't know. We'll see. Let's go and do it. I'm seeing a bunch of 4s and 8s. That's going to be nice. Okay. So T is at 8, 4. U is at negative 4, 4. R is at negative 4, negative 8. And S is at 8, negative 8. So to dilate by 1/4, we're just going to multiply each of those times 1/4, aka divide by 4. Push. If we do everything right, the shape should be maintained, and we should end up with something where all the sides are 1/4 as long as the original. I think it fits. Yes. When the pass comes back, are you able to wait? If you get to the point that you can't, just go ahead and go. There it is. You're up. All right, folks, how are we doing? Couple more. Any questions before we move on? Thank you for helping me out with my mistakes on example 2. Example 3 went a little bit smoother. Let's see how we can do on this. All right, you guys want to do the origin again, or you want to do something trickier? Okay, fine, we'll do the origin. You guys go ahead and do it. Dilate by about the origin by a factor of 3. That's what this one says, right? Factor of 3. So we're making something that's going to be 3 times as big linearly. I'll leave it to you if you want to count or find coordinates. I find it easier to find the coordinates of the original and just multiply them. But if you like counting, then you can just count. But go ahead and do it. Don't wait for me to do it. Do it on your page. We're almost done. What questions do we have? Are we feeling pretty good about this? Let's say for right now, we're going to stick to dilating about the origin. Show me your thumb meter for dilating figures about the origin. Are we good? Little practice. How about, and let's also assume that the axes are clearly marked and not tricky and in between like the last ones. Are we good on this? Okay. Last one here. Let's just focus on the scale factor for this one. If I were to ask you, stick with me here for just a couple more minutes, guys. If I were to ask you to find the scale factor for this, what would be the easiest way to tackle that? There's several ways to do it. So you're looking at the sides of the small triangle and the big triangle. That'd be one way to do it. Like you could look at this and say, how big is this?
2.
And how big is this? 4. So what's my scale factor? What do I multiply 2 by? Equals 4. So our scale factor comes out to be 2. That'd probably be the easiest way to do it. We could check it. We could check it by saying, oh, this side is 3, and this side is 1, 2, 3, 4, 6. That's twice as big as this, so my scale factor must be 2. The other way we could do it, since they did tell us, did they tell us it was dilated about the origin?
Yeah.
I don't see about the origin anywhere. It doesn't say. So we're kind of stuck with that. We basically have to look at the sides. We know that the scale factor is always going to multiply the original size to get you the bigger size. So it's 2 times something equals 4. Obviously, that's 2. While we're here, this is a little bit more advanced than we need. Where was the center of dilation for this? Let me show you how to find the center of dilation if this ever comes up. Guys, let me get your attention really quick. This is our last thing. If you take a ruler and you connect a point, an image with its original point, and draw a line, and if you do that with all of the points, those lines will all come together at one single point, and I didn't make these two long enough. And that will be your center of dilation. So those lines all come together at a single point. It looks like it's down here someplace. It's not the origin this time. I'm guessing it's going to be like -2, -3 or something like that. Okay, but your center of dilation will always line up with your points and your original points and your new points. So you can trace them backwards. This reminds me of a fun astronomy question. Have you guys ever heard of red shifting and blue shifting stars? So when you look at stars and the light's coming from stars, some of the stars appear slightly red and some appear slightly blue. And it's this thing called the Doppler effect. Stars that are moving towards us have is it red or blue? I can't remember. One of them corresponds to moving towards us, one of them corresponds to moving away. Okay? So if the theory of the Big Bang is true, and all of the stars are kind of moving away from each other, which is kind of how they came up with that theory, then theoretically you should be able to draw some lines from those stars in the direction that they're moving and figure out where the center of the universe is. Kind of like we did with this, right? And they have actually done the calculations on this. They've taken hundreds and hundreds of stars and figured out what direction they're moving away from us, and they've traced them back to the center of the universe. And you know where it is? It is right here. Yes. I am actually the center of the universe. It turns out if you do that math from where I'm sitting right near, this is the center of the universe. However, if you do the math from where you're sitting, the same math, you're going to get a different answer. You're going to get that you're the center of the universe. And if you do the math from over there, then you're the center of the universe. So and this is based off of astronomy. So next time your parents ask you, what do you think you're the center of the universe? You can tell them, well, actually, if you trace the movement of all the stars back to one point, it is right here. So, all right. Your assignment's on the back of the packet. Let's get busy on that. Folks, could you please have your Chapter 2 packet out so that I can get that last stamp sheet taken care of?